Good morning everyone. Today I'm presenting AccessibleHub, so an accessibility learning toolkit for developers to teach how to bridge theoretical implementation between practical code guidelines. And you will see this is a framework is established not only to understand how to implement something formally, but how to bridge it in practice. So the first set stage talking about mobile accessibility. So what is it? We talk about how users of whatever kind are able to perceive mobile content in whatever kind of form, which means that it's not only perceivable but understandable. We see that this is a very big percentage of users since today is a mobile first era. So not only there is implementation to consider within a context open to many users, but to be adapted within different ways of interactions. We talk about, in fact, about accessibility barriers, which means that not only we have to consider different screen sizes, but also different ways of interactions, like orientation changes, meaning vertical versus horizontal, and performance impact, because these are mostly low-end devices. So we talk about battery, memory issues, something like that. We want to set the stage talking about these and what are the guidelines that can be used within a formal context. So we talk about, for example, the standards used. First, from the web-focused environment. So we start within WCAG, Web Content Accessibility Guidelines, established by W3C, creating many web standards up to this point. Point is, they tried to make it more general as possible. It is a framework indeed. So we have different principles talking about if some content is considered perceivable, understandable, operable, and robust, and if this is conformant to not only legal standards but practical standards. Problem is, it's mostly web focused. So they tried themselves with W3C to bridge the gap between mobile content accessibility guidelines with mobile specific criteria, which once again is criteria more for, I don't know, touch, target sizing, orientation of set devices, but once again general. Lastly, UCAG Mobile, which are only mainly interpretations. It's a draft which came out in April 2025, also to be considered in this research. What's the point here? Well, from the point of view of developers, there is no actual implementation in a standard way, because there is no chance for a developer starting from scratch within projects to understand how to implement not only an accessible way of development, but also how to make it into code, into practice. So, of course, developers try to do that in a developer way, understanding forums, resources scattered throughout the web. So there is a lack within that. And not only that, of course, but the differences between platforms, so Android and iOS, which are the main operating system that we everyday use. We talk about how not only by the accessible point of view, but users interact within set devices. So we have, for example, talkback and voiceover, which announce what the content is present, how it is. We will see briefly an example about that, and also other kinds of gestures. So for example, voice controller, which is used for alternatives over touch-based gestures. Lastly, we talk about switch control and switch access, allowing external devices to interact within set content. In this research, I also considered the main cross-platform frameworks inside of development. We will discuss them in detail later. What's the gap here? Well, basically, it is based over a research which was only theoretical over the Flutter framework. In this case, they were analyzed components from the code point of view, and discussing about UCAG, we tried, in this case, the student only to apply new guidelines and understand how to bridge the gap. But still, gap is present for developers. This is where AccessibleHub comes in, which is the application that I realized within React Native as framework. In this case, this is an application tested with both Android and iOS that tries to bridge the gap within said research, mainly answering three questions, which you can see here. So, in this case, are React Native components accessible by default, which means do we have to add some portions of code or do we have to invent it from scratch? Because once again, accessibility cannot be invented up to a certain point. We have to make something precise to be used. So, can, and the second question, can an accessible component be made accessible? Which means not only adding code, but understanding if there is some kind of way to make it standard, of course using the theoretical guidelines. And what's the implementation cost? So what is the code overhead? What do we need to add, and is such the adding of code impacting the logical complexity of said component? So the goal is bridging VCAG theory to practice. We're going to see an example now of how the screen reader within Android talkback interacts. So you can see some of the screens of the application. Okay. So we're going to see briefly how not only the home screens, the name sections, and how the screen readers gives focus to different elements over the screen. Okay. So you can see that the goal already of a screen reader is to read all of the elements on the screen. Of course, the pronunciation is a bit botched because the device is in Italian, but the screen reader announces English. I mean, it's not a problem in that. So already this is a non-standard implementation because this is not present within React Native. It's a code added by me. So in this case, not only we try to apply VCAG guidelines, but we try to bridge that, adding or understanding for categories of components what code to add. Okay. So we're going to briefly see how we focus on this. You can see that it's pretty long, but this is the goal. Perfect. You're going to see, of course, a framework comparison into the detail within the next slides. Just to make you see the screen and how it is even focused by the screen reader. So everything, in order to be made like that, needs properties that we're going to see within both frameworks, how to bridge it into practice. And this required not only testing within the platforms, but some adjustments between code in order to make it everything completely announced. So you see that testing screen readers is not something completely easy. It takes longer, but taking only some measurements of code, it can be shown easily that accessibility is something that we can implement directly into projects. So I come back to the slide in order to make you see by time. Okay, this is another important part of the application. Okay. Of the application from which we take, for example, components, and this is a section on which you can see different categories of video we're going to discuss briefly now are to be implemented within projects. So there is an implementation of a button, and then one can easily copy the code within accessibility properties and directly implement it inside of a real project. Okay. We come back to the theoretical analysis. So what's the goal here? Well, to translate theory to practice, we require precision. So in this case, it was based mainly over 4 layers, starting from the theoretical foundation given by the guidelines, VCAG, and then extending that to more and more specific success criteria. What does it mean? It means that not only we see how the content is clear, but if within the mobile context a title is announced clearly, etc. Secondly, how to implement it in code, because theory is good, but not when we have to make it into practice. So in this case, not only we understand how to make it in code, but how to make it formally. So there are metrics that we discussed now. Also, screen readers, which is a very important component. So you can see that these metrics, you're going to see, discuss how clearly said screen readers read, announce, give focus to certain components. Lastly, because this is across the platform, so we want to make it as precise and as objective as possible, an educational tool, which is the platform integration. Enables data-driven accessibility metrics, which means that we bridge theory to practice into an effective and formal way. So, in this case, we give focus to the screen that we briefly just saw. In this case, what does it mean from the point of view of theory and practice? We take a screen, set accessible components, What does it mean accessible components? General categories of media we can interact with. So the buttons, which was the screen that you saw just now, forms media, talking about images. So to make images accessible, we give alternative text within them. How is it basically mapped? Well, there is a criteria. So basically, we take the code and we map it into not only the semantic role, because in accessibility, one of the main important things to add is, do we know exactly what does it do? So in this case, it is clear to screen readers, but also external devices, how something we can interact with. Because then not everything is standard. In this case, mapping into code means we give the role to be scrolled, so to move within fingers, and also the announcement of the header, which is the title that you can see. So this is to be mapped within a specific criteria, because this was not invented from scratch from the special criteria. You see focus management, keyboard focus, if we go into set components, and then we apply more and more criteria to understand if it was navigated well within mobile content, etc. So we also go, this is a three-step procedure, this is the second one, and in this case we see a snippet of code of said screen that we saw just now. In this case, not only we analyze the code, but also given the analysis that was conducted for, I think there were 19 screens within the different components, so you can understand the importance that this generally has. It was announced, and screen readers have specific, similar but different criteria, because not only we want to understand if something is announced clearly, but if there is focus management, it means can we, with the swipe navigation, basically the tab within devices, so can we browse there, can we reach set content? This is the hierarchy, so this is the navigation decisions that we describe here. So this is a very brief example of the screen we just saw. And in this case, not only understand the lines of code, so how does it mean writing exact lines of code to be properly introduced, but also the logical complexity. So I discussed briefly before about the breadcrumb and the drawer, which means that in this case, this is not given the framework something that, well, you have the breadcrumb, go ahead and implement it. So in this case, this requires a higher complexity over this column says the percentage of total code added to make certain components accessible, which means that this is not present from scratch. We reach effectively metrics and practice within something that it's not completely standard, but this is a very generic template in order to make it. So the overhead basically is quite understandable from 36% for this specific screen. This analysis was conducted precisely for basically every single screen of the application. And in this case, given the theory, we reach it into practice, of course, in a possibly general way. We do that with a systematic correlation. So in this case, we talk about the different kind of components. Components are given the framework to mean that we want to develop something within buttons, within forms, within images. So when we use them generally, we try to understand how is the impact of the thing code using a React Native as baseline. So basically given the AccessibleHub implementation. Well, this is a framework agnostic, which means that this measurement was trying to bridging not only React Native, of course, but Flutter, which is the other framework, and iOS and Android. So we try to be as general as possible within a threshold of 25% overhead for not only the simpler components, require only semantic roles, because in this case we describe the content, we give a few informative lines. Then we go from dialogues and forms, which are something that requires state management. Does the user make an error within forms? We have to consider them. Are there specific kinds of buttons? Are there pickers for time and date, something that we use every day? This is not so much to take for granted within mobile content in general, apart from accessibility. Lastly, advanced, which means we talk about components completely usually non-standard, so sliders, progress bars, alerts, something like that. And in this case, how was it made? Well, we talk about the metrics used formally to evaluate something like that. We briefly discussed already about the overhead. So we try to make metrics without as general as possible, but of course precise and based over objective data, which is the case, as said, of implementation of overhead. What is the code that we need to add in order to make it equivalently accessible? So the second one is the screen reader support score. A good title to say, like from 1 to 5, is something given the focus clearly? Do we have something in which the role of an header of a title is communicated clearly, etc.? This is not by chance, but by conformance titles. So these are the levels given by CAG, which are basically levels to say everything is fully compliant, everything is legally compliant, or the bare minimum compliant. Also the complexity, these last ones are more software engineering based, because in this case we talk not only, you can say, about the complexity of components. So we require 1,000 lines more code. This is more complex. Also forms can be complex by the point of view of browsing, etc. Lastly, we talk about development type estimate. Very general to understand that if the nesting depth for said code is too much, if there are requirements within a loop, an if, a condition and something. So you can see that this is mostly based over developer focus, which is the goal of the slide here. So we talk about the frameworks now that you briefly saw before. So we give focus, quote unquote, to React Native as of now. React Native is more keen over the web-based approach. So we take a component and we give them specific accessibility properties for the component, which means that not only we can take the component, in this case a title text, and we give it the goal that we want to achieve a set component. So save the document over functions that can be called, integrated directly into the component. Flutter, which is the other cross-platform development framework, takes a more general approach, because in this case there is something to adapt. So there is an external widget, an external component. In this case we give properties not only to the components but also the children if possible. This is to be made within code via the semantics. So in this case we give semantic, which already the etymology suggests something, means the meaning of the said component. We go on to the results mapping. So in this case, the most important result is that the overhead from Flutter takes 120% more code. Not only by the simpler, we might say, components. In this case, the text language means translation of said components. The one we tried to see before with the Italian/English pronunciation. Headings, titles, so in this case from 20% to 50%, as soon as the complexity of the components arise, given the metrics we try to be as formal as possible and as objective as possible, we see that they achieve mostly similar results, and in this case, screen reader support is pretty consistent between the two, with React Native scoring higher in this case, because it provides, given the metrics, more out-of-the-box features within the field of accessibility. And to complete what we saw 2 slides before, so the code integration, in this case, this is a table just to make developers understand what to prefer to compare to the other. So in this case, code integration, React Native maps directly properties into the component. Why did I say web-based? Because within web we describe the formatting of something. We don't code it from scratch. It is the approach taken, in this case, by Flutter. So in this case, not only Flutter achieves circa 120% more code, by the point of view of the metrics given, the learning curve that we can see is a bit steeper in the case of Flutter. Even if this is a more general, robust approach, but to be understood first and foremost in order to make it applicable. Both require intervention. This is not like some frameworks declaring their website like Flutter does. I'm the most accessible framework. No, this is not like that. And there is objective data showing exactly what we are trying to discuss. With React Native achieving a mostly better consistency. And this is the third point within the fifth. So we can see that they both achieve a very high degrees of compliance by the point of view of the formal guidelines, but they don't reach 100%. And in this case, we have to add code in order to, there is always the intervention from the developer to reach something like that. Because once again, this is not made from from scratch, but it is code that we have to add. So to conclude, in this case, this methodology is something systematic, which tries not only to give systematic evaluation for categories and components and bridging theory to practice, but the first, to my knowledge, quantitative framework for cross-platform accessibility decisions. In this case, we see that not only accessibility becomes something which is not an afterthought, but something that we have to think within the development, because in this way it is easier. In fact, answering the question before, no framework is accessible by default, which means that both require intervention. In this case, they can achieve equally higher compliance, between 85 to a bit more than 90%, with React Native consistence of 45% less code for the equivalent functionality that we have just discussed. So this is the conclusion from me, and in case you have questions, this is the right time. Okay. So thank you.
So I have a general question. So within your thesis, what was the most, the hardest part, let's say, and why?
The hardest part was to understand, because there is no comprehensive developer documentation. So to understand how to bridge, not only because the code is something that looking at documentation or looking at resources, you take a bit of that, take a bit of this, and then you merge it together. But to make it so that we understand how to respect the vocabulary, because this is a baseline. I try to look it from the external point of view, not as you have to do that, that, and that, but understanding if there was an effective way to do so. So within the middle of this development process, I try to say, in this case, it is important to understand the categories of the application, because I thought not only the application but the theory, and how to bridge it. So in that case, the mapping was something that I tried to implement myself, because to me was the most effective part. So you can directly see you have this that you can make in this way. And this is a very, for me, framework-like approach. So you understand, okay, you have the title, you make it this way, because it respects this, and that, the guidelines. Then, to add content within this, and also, because it was basically 4 or 5 months into development, the part of WCAG to mobile. So to say, are the WCAG general enough, or can we apply something more? So, given the code, given the WCAG, I also add after the WCAG to mobile, to give even more precise mapping to be used in the future. So the hardest part was basically this, the overall bridging part to give a general answer. And then everything came within the process. And also some guidance, of course, by my supervisor to understand how to make it, but it was mostly by me that mapping, you want to say. Thank you.
Also maybe to fight against the hardware, to be able to...
It was a fight, not only required to develop this into Windows within from scratch, for React Native from 2 or 3 weeks in order to for everything to work, and then the fight for certificates to install on iPhone, and so this was a fight from my supervisor there for part.
Were there any costs for developing on iOS?
From my part, no. I think probably the certificates, I don't know if there is some signing, but probably, I mean, no, in the case of Android, no.
Working on this because we had some problem with university.
Yeah.
So basically, I also made a tutorial for Windows users in order to understand how to do React Native, which has from 3,000 to 4,000 users. So I think it helped because there was no standard. So there is something on cloud, something local, and it's a burden.
I have one. I think that you have made a huge work, but when you define just to be more complete as possible. Okay. When you define which is the limitation of your work, in particular when you define how to judge the different submetrics.
Basically the matrix.
Okay. There are some limitations in the metric that you define.
Well, in this case, yes. I think that the most important limitation might be the screen reader ones, because screen reader one, because in this case the measurement was we tried to make it as framework-like as possible. So I define myself a liker scale based on different criteria. within the role announcement, the gesture support, and it is something that was empirically measured, so to understand if this is announced clearly or not. But the main point not only is the personalized scale, it will require some more technical users, because there were mostly trials and errors, you can say, made by me, but it will require for a more objective analysis, a pool of developers, or some users that have some kind of understanding within the context, and also because target compliance is something that you cannot invent. The criteria is there, so you try to apply and to see what is something to apply. Also, we might say definitely the complexity and specifically the development time, because this is the most important one, I would say. The case nesting depth and dependency requirements, yes, it's objective, but depends on the habit that the developer has within code development. So, and okay.
Okay. Thank you very much.
Thank you.